Good day, my viewers. I welcome you to our continuation learning series of science and mathematics education. Which subject are we looking at today, and which topic? We are going to be looking at the subject physics, and the topic before us is on what? Velocity times graph. On this today's edition, velocity times graph simply means a graph in which we normally plot the velocity against time in order to calculate what at times distance. So we normally plot the velocity on the vertical axis, and then your time is going to be what? Horizontal axis. So we normally plot velocity against time like this. So we want to look at a question you can solve using this velocity times graph. Now let's take a look at a typical question where we normally solve question on this velocity times graph. Here we have a question. A car starts from rest and accelerates uniformly until it reaches a velocity of 40 meters per second, which is going to be the final velocity. And after 5 seconds, it travels with uniform velocity for 15 seconds, that is for the next 15 seconds, and is then brought to rest in 10 seconds with uniform retardation. You now say we should find the acceleration of the car. Number 2, retardation of the car. The third one, the distance covered after 5 seconds. And number 4, the total distance covered. So how do we solve this kind of equation? This is a typical velocity times graph. Why? Because we are being given what? Velocity and time. We are being told to calculate what? Distance. So let's go over it. Having said that, we now go over the solution. Let's solve it. So like I've said, velocity time graph. Your velocity is on the vertical, your time is on horizontal like this. So here we are, velocity meter per second. Here we have time on the horizontal axis. So we are being told that the car accelerates. It reaches velocity of 40 meters per second square. So we are going to say it accelerates, move like this. Okay, so the maximum velocity here is 40 meters. What is the time taken during that duration? It's spent what? 5 seconds after 5 seconds. Okay, fine. Now, if you look at it, now that it travels with uniform velocity for 15 seconds. So it now move for the next 15 seconds like this. Like this. So 15, from here to here is 15. 15 plus 5 will give us what? 20. This is not the what? 20. How do we get 20? You added the next 15 seconds from the original 5, giving us 20 seconds. Okay. Now, they now say that it then is then brought to rest in 10 seconds with uniform retardation. Coming down is retardation in the next word, in the next 10 seconds. So 10 plus 20 give us what? 30. So that's what we are saying. So this is a retardation brought down, acceleration going up. So this is how our graph is going to look like. Okay, now let us now solve the question. Let's say find the acceleration of the car. Acceleration. So this is the duration. We can number our graph as O, A, B. It forms a trapezium, OB. E, D, and C. You can give it any label. O, A, B, C, D, and E. You can label like that. It forms a form of what? Trapezium. Okay, we are going to go trapezium now. Now I want to find the acceleration. So for the first one, the acceleration. So for the journey. So it's going to be within this region. Okay, so acceleration taken is going to be what? The AE changes in velocity. AE all over what? EO. Why? What is AE? AE is what? Changes in velocity. Initial velocity, final velocity. That's why give us what? 40. Okay, so our initial velocity is 0. Our final velocity is what? Is 40. Like I've said, acceleration of changes in velocity per time taken. So 40 all over, what is our time duration? Is 5. Okay, So 40 divided by 5, automatically you are going to what? 8 meter per second square. So that is the acceleration of the car. Okay, now what about the retardation? Retardation means coming down, opposite of acceleration. So you now see retardation now is coming down. Retardation. What is retardation? We can see from retardation as well. So this one now be what? BD. Now be what? BD all over what? D what? DC. All over DC. Yes. All over DC. What do you mean by that? That is going to be what? Changes in the velocity. This one all over what? The time taken for the duration. DC. So within this time, this is the what? Retardation or deceleration. This is what? Acceleration. Coming down is deceleration or retardation. What is BD? That's going to be what? 20 all over what? 10. Difference between, we take away 20 from 30, give us what? It's going to give us 10. So now add that on to the what? 10. Okay? So 10. Sorry, this is our 40 as well. 40. BD is what? 40. You trace it. 40. Okay, your time, that is what? 20. So this is what? 40 all over what? Time changes. 10. So now 40 divided 0 cancels 0. 4 here divided square. So 4 divided by 1 give us what? 4. Okay. So we are going to calculate the acceleration during this journey, deceleration, changes in the what? In the velocity of the time. Remove 20 from 10 give us what? 10. So that's it. Remove 5 give us what? So that we got this one time. Now what about the third question? The distance covered after 5 seconds. Distance covered after 5 seconds. So the distance covered within this duration after 5 seconds. What is the distance? So now say distance covered. Distance covered. Distance covered. Distance covered after 5 seconds. So how do you solve that? And we have known that the equations of motion, I have told us that u v plus u all over 2 multiplied by t under the equations of motion in the last